Hey all, today we are going to start talking about measures of position. We have talked about how to find the center of data sets, how to find out how data sets vary by finding things like variance and range and standard deviation. And today we're going to talk about positions of individual data points, specifically as they relate to the rest of the data set. The first measure of position we're going to talk about is a standard score, which we also refer to as a z-score. This may or may not be something you're familiar with, but of course we'll talk about it here. So in this scenario, we have a student who took an English test and they took a French test. And so we want to see which test they did better on relative to their classmates who also took the English test and the French test. And so it's hard to compare a score on a test in one class or one subject to a test in another subject. A lot of times they're very different. Their levels might be different. But one way we can do that is by standardizing those scores using a z-score and then measuring their position relative to the rest of the class. So we have this formula, and we are going to use the formula for samples because we typically have samples. And the letter X here represents the data point. X bar with the bar on top is our mean. And S is our standard deviation. And so what this does is when we calculate a z-score, it tells us how far away from the average score is our specific score. If it's a positive value, that means we're above the average. If it's a negative value, it means we're below the average. And the larger the number, the further away we are. So for our English test, we can calculate a z-score. 85 is our actual score, and we can subtract from that the mean, which is 76. And we'll divide that by the standard deviation. A z-score is actually going to tell us how many standard deviations we are away from the mean score. So in this case, we get 2.25. It's a positive value, which means the student scored above the mean. We already knew that to be true. 85 is higher than 76. This tells us, though, that this person scored just over 2 standard deviations above the mean, which is pretty far above the mean. We can look at their French score. They scored a 42. The average was a 36. So we know it's going to be a positive value. They scored higher than the average. Standard deviation of 3. And we get a value of 2. So they are still two standard deviations above the mean, but they're still just slightly closer to the mean in the French class than they are in the English class. So of course 85 is better than 42, but when we want to compare two different subjects directly, if we calculate these z-scores, we can in fact say that they did better in English compared to the English class than they did in French, even though in both classes they scored above the mean. Want to do another one. This one is about marriage and the age at which men and women get married. And so I can, again, I can calculate a z-score for a 24-year-old man. When we say that men have an average age of marrying at 26.4 years with a standard deviation of 2, we know this is going to be a negative value because our person's age is less than the mean. Negative doesn't necessarily mean bad. It just means it's below average. And so we get negative 1.2. That means they're just a little bit more than 1 standard deviation below the average marrying age. For our woman, she is 22, and there is an average age of being married as 23.5 with a standard deviation of 2.3. Again, we know we're going to have a negative value because she is younger than the average age of being married. And we get negative 0.6521. The bigger the z-score, the more unusual, or I should say the further away from the mean, the more unusual a value is. And so even though our woman is younger when she gets married than the man in this problem, it's less unusual for her to be married at 22 than the 24-year-old man. She has a z-score that is smaller. It's less than -1, so it's pretty close to the mean. Whereas the man has a z-score of -1.2. It's not really big, but it's bigger than hers, and so it's more unusual. It's not really unusual, but it's more unusual for comparing them for this man to be married at 24 than the woman to be married at 22 based on our information. Another way that we can measure position of a value is using percentiles. And so what we would want to do is enter this data into an Excel, or we could just write, if we have a small data set, we can write these numbers in order from smallest to largest, but we want to have them in order so we can see which are smallest and which our largest is. So it would be a good idea here to pause and to put them into Excel. So I've put my data into Excel and I've organized it from smallest to biggest. And so I want to find the percentile rank of the 16 traffic violation data point for this 10-day period. And so the way I calculate that, I'm going to use P for percentile, is I take the number of values below X. So number less than X, X is our data point. And I'm going to add 0.5, divide by the number of data points, and then multiply by 100, so that becomes a percentage. So if we look at the number of data points that are less than 16, there are 3 of them. And so that is our number less than X. There are 3 values less than our data point we're interested in. We're going to add 0.5. We have 10 data points, and then we're multiplying by 100. We get 35. And so that means this 16 violations we will consider to be the 35th percentile. So we are using this formula and the data set to calculate the percentile that a data point is in. I'm going to be using the same data set the whole time, so we don't have to create a new one. Here we want to know the percentile rank of the 24 traffic violations. And so if we look, there were 8 traffic violations less than 24. So our first number is 8. We're going to add 0.5 to that. We're going to divide it by the total number of days, which was 10, and then we multiply by 100 so that we turn it into a percentage. If we want to turn a decimal into a percentage, we multiply by 100. The other way to think about that is we can move the decimal place 2 places to the right. So when we do that, we get 85, which means 24 violations is in the 85th percentile. So here we're just kind of plugging into a formula. We can use our worksheet to order the values for us. You can order those values on your own if you would prefer that. You want to take a break from Excel, but you know Excel will do it for you pretty quickly. We can also do the reverse of that. Perhaps we want to know, hey, what number of violations would represent the 65th percentile? That means that 65% of the data points are would be below it. So we have this formula. which is really just our other formula reworked. So if we consider this C, hang on one second. I should say the top of this fraction, if we call that C, that's what we are referring to here. We just really rework or manipulate that equation to get this new equation. N is the number, in this case, number of days. P is the percentile. Before we were multiplying by 100, now we are dividing by 100 to take that percentile and turn it into a regular value. And so here we have 10 days of violations. We want to know the value at the 65th percentile. And we get this value of 6.5. And this is where we're not totally done. We need to use that 6.5. Whenever we are doing this process and we get a value that is a fraction or a decimal, I should say, we're always going to round up. So round up when it's a decimal. So we round to 7. That means the 7th data point. So the 65th percentile is represented by the 7th data point. So if we look here, our 7th data point is that data point of 20 violations. That represents our 65th percentile. Let's do one more. Here we'll find one for the 30th percentile. We can use this formula, and I always recommend in any math class I do or any class you take where there's formulas that you want to make sure that you're comfortable with and you remember and you're using properly, that you should write that formula down every time you use it. So again, we have 10 days worth of violations. Now we want to use or find the 30th percentile. And so we get 3. And so when it's a decimal, when we get a decimal here, we're going to round up to the nearest whole number. When we get a whole number, we're actually going to go between this number and the next nearest whole number, which is actually, let me rephrase that. We are going to find our third value. And we are going to go between our third value and that value plus 1. So we're going to go between 15 and 15 plus 1, which is 16, and say that it's 15.5 violations. So leaving out the science behind that, the process is when we have a whole number, we go find our third value, which was 15. And then we are going to find the number between the third and fourth value. So our fourth value here was 16. And so that gives us 15.5 violations. These are the type of things that do take practice. So the more you do them, the more comfortable you will be with them. We are just trying to implement this process. So I have some I want you to try. I have one about Z-score and then one about percentiles. Please do try them. Pause the video now, try them on your own, and then when you press play and watch on, I will talk about the answers. So hopefully for the first one, you got a Z value of 0.75. So 0.75 standard deviations above the mean. So this 27-year-old woman was 0.75 standard deviations above the average marrying age of 24.6. For this one, the population that represents the 40th percentile is 21,000. So we plugged into our formula, you get 10.8. So that's approximately, we round it up to 11. Our 11th data point is 21. This last one for a data value of 27, that is the 16th value. We plug that into our formula, we get that is the 61st percentile. If you got one or more of those wrong, please do call me over and ask, and we can find any mistake that exists and have a conversation about them. If you've done that or you've gotten them all right, please move on to the practice items. While you're working through the practice, at any point, if you have questions, please feel free to ask.